This is IAT806 Lecture 3, Part 3.1. We're going to now talk about polygons. So our motivating problem for Lecture 3 is that what we want to do is to draw an n-sided polygon. That is to say, a polygon with n sides. N is a number 3 or greater. So we're going to show a 5-sided polygon for the examples. We'd like to store the x and y locations of each of the polygon's vertices somewhere reasonable, and we'd like to be able to move the polygon around with a minimal amount of programming work. And so what I'm going to do is show you the techniques that we can use that are built into processing, as well as techniques that are part of the Java programming language to be able to at least store and move the polygons around. So first, let's start with building polygons. And what that means is we would need to issue a command that says to processing's graphics system, there's a polygon coming. And we do that by issuing calling the method beginShape. And beginShape takes a number of possible arguments, and behind the scenes these are essentially constant values, and that's why they're spelled with all capitals here. So the value that we will use for a polygon is, surprise, polygon. And what this does is tells the program processing to start a polygon. After beginShape, the next lines of code have specify what are the x and y locations of each of the vertices of the polygons. And you can make as many calls to vertex as you like, although I think there's probably an upper limit of some power of 2, like 512 or 1024 or something. But practically you can do as many as you want, and most people don't want to do more than, say, 10 or 12 or something. Lastly, for a particular polygon, you call the method endShape and say another keyword for the polygon calls, for the shape calls, close. And that's another behind-the-scenes constant that has been created by the processing system. And what endShape does is finishes the shape and connects the last vertex to the first vertex that you issued, the first vertex call immediately following beginShape, to close the polygon. And it also fills the polygon in with the current fill color. It also, of course, draws the outline of the polygon with the stroke color. Okay, so let's just show what that looks like, as it were, step by step, just to outline it in the slides, and then we'll go to the processing window and show a piece of code that does exactly this. Okay, so first we do beginShape with the argument polygon, and then vertex 1050. And we're going to use a blown up version of the standard window, which is 100 across by 100 pixels down. And that would place a vertex here at this location, 10, x equals 10, y equals 50, which is about halfway down the standard 100 by 100 window. Next, as we issue the subsequent vertex calls, it specifies the next vertex to be 2010, the next one to be 3040, next 8060, and the last one here, 4080. And so this adds 4 more points to the polygon that is being specified and puts them in the order in which those vertex calls are issued. Finally, when we issue the call endShape to processing with the command, with the argument close, then that signals to the processing system that it is now actually time to draw the actual polygon, right? So now let's show what that looks like in the processing system. So here I've typed in advance all the parameters, all the code that we saw in the slides. We have beginShape polygon, vertex 1050, 2010, 3040, 8060, 4080, and then endShape close. And I'm just showing the scripting interface to processing without a setup or a draw methods being defined. And so it'll just execute this once, and we'll just see what that looks like. So there it is. And once again, I'm using the 100 by 100 window, and I've expanded it so you can see clearly what's going on. So there's the first vertex, the second one, third, fourth, fifth, and it's closed. So we have a line segment from the last vertex to the first vertex. Great. So that indicates how to draw a polygon. Now, what I'd like to show you as I move back to the slides is that you can also parameterize beginShape with different arguments. Previously, we'd just shown polygon as the type of shape that is going to appear. The beginShape and endShape calls, however, are a little bit more flexible than that, and they allow us to draw irregular shapes from any number of points that we define. And there are many types of shape. So let's now do points. So I'll go back to the processing window, and instead of polygon, we'll put points as the parameter to beginShape. We'll stop it and press play. And there you see, once again, that the window has popped up, but instead of getting a filled polygon around these vertices, instead we're getting individual single pixel points at those same geometric locations. There's no line segments drawn between them, and of course there's no filling, because what we're doing is we're telling the telling processing to draw points using each of these vertices as the location of a single point. Now we'll do lines. Now the eagle-eyed amongst you will probably notice that we have, oops, spell lines right, that would be good, not lineses. Okay, and the eagle-eyed amongst you will notice that, no doubt, that there are 5 vertices, and you need pairs of vertices to draw line segments. So what we'll in fact get is that the 5th vertex will end up getting ignored, but we can still issue the beginShape with lines call. So let me show how that looks. So there's the 1st and 2nd vertex, the 3rd and 4th vertex. The 5th vertex has been ignored because there was no 6th vertex to follow it. So we just get those 2 line segments, whereas we'd seen 5 points in the previous run. Now let's show triangles. And that is not triangulous. There we go. Not triangles either. Triangles. There we go. It's hard to type and talk at the same time. Okay, now let's triangles, and what we'll get is, because there's 5 vertices, we'll only get 1 triangle, which is constructed from the first 3 vertices. The other 2 vertices are ignored because you need sets of 3 vertices in order for this to get a full triangle, and we don't have a second set of 3 vertices. Okay, now let's try triangle strip. And what triangle strip does is it takes the first 3 vertices to create a triangle, and every subsequent vertex adds another triangle by taking the 2 previous vertex locations and constructing a triangle out of these 3 vertices first, and then these 3 vertices when you add this one and drop the first one off, and then finally these 3 vertices when you drop the second one off and add the 5th one on. So it seems a little confusing, but let me show you. So there we have the 1st, 2nd, and 3rd vertex. When we issued the 4th vertex, that's located here, it dropped this one and created a triangle from the 1st and the 2nd, and from the 2nd, the 3rd, and the 4th vertex. And then when we issued this vertex, it dropped that one and added this one, creating a triangle here. Now finally, let's do triangle fan. And what this one does is create a triangle from the first 3 vertices, and then reuses over and over the first vertex to create essentially a fan shape from the vertices that are issued in the call. So let's just do that. And there we see, once again, the first triangle, the second triangle, and the 3rd triangle. And what's going on is that this vertex is in common, and this pair is used, then this pair is used, and then this pair of vertices is used. So once again, it's an incremental drawing. Okay, so as I say in the slides, probably polygon is the most useful. But one of the advantages of saying beginShape at issuing a bunch of vertex calls and then endShape is that it's reasonably efficient in terms of execution time to just issue vertex after vertex after vertex and specify just once that a number of shapes are going to be specified by a sequence of vertices. And that turns out to be a reasonably efficient use of computer time to specify what shape you want once, and then issue tons and tons of vertices with a bunch of shapes that are intended to follow. Okay, so that's the end of lecture 3.1, where we spoke of polygons.